Lesson 8.1 in our math book today is going to be focusing on volume of cylinders. Our objective for the day is going to be able to find the volume of cylinders. So we're going to be taking a look at a couple different examples of cylinders that are going to be in our book. I'm going to be talking about how to find the volume of them and what we need to do with that. First of all, a couple vocabulary words that we will be talking about or that will be new to most of you in this lesson. There are three of them. The first one is volume. The second one is cylinder, and the third one is composite solids. As you can see here on page 590, if you have your textbook or on the screen, you can see that volume is going to be the measure of space that is occupied by the solid. So I like to think of volume as how much a figure can hold or an object can hold. When we think about the volume of a cylinder, there are two formulas that your book talks about. The first one, as you can see, is V equals capital BH. And the other one is V equals pi times radius squared times height. The one thing we need to remember when we're looking at V equals capital BH is the fact that that capital B is there for a reason. Anytime we see a capital B, that's going to indicate that that means the base area of a figure. So what we need to do when we're looking at our three-dimensional figures is look at the base of it and ask yourself, what shape is it? So one of the things we need to think about is this capital B is here, because when we look over here, the pi times radius squared is taking the place of that capital B. The pi times radius squared would be the area of a circle, as you can see here. So we're going to take the area of our circle, and we're going to take it times our height. Remember, pi, you can use your pi key on your calculator, or if it specifically tells you to use 3.14, please do that. R, remember, stands for radius. Radius is the point from the center to the outside of the circle. As you can see at the top here, they have the midpoint or the center of the circle marked. The red line indicates your radius, and we're squaring that. So for example, if our radius was 2, we would take 2 times 2. If our radius was 5, we're thinking 5 times 5. The H stands for the height of it, so you're looking at your cylinder and asking yourself, what is the actual height of that? All right. Remembering that with cylinders are going to be three-dimensional figures that are going to have circles for their bases. There are going to be two bases. All right. You're going to have a circle on the top and you're going to have a circle on the bottom. So as we take a look here at two examples that your book has given you, number one says find the volume of the cylinder and round to the nearest tenth. You're going to notice they are not telling you specifically to use 3.14, so you can go ahead and use the pi key on your calculator. Again, we're going to start off with V equaling pi times radius squared times height. I would practice writing that formula out and getting used to that. Again, the pi times radius squared is taking the place of the capital B. You do not need to put the capital B in there. You can go ahead and start with the pi times radius squared right away. So as we take a look at our figure over here, again, pi would be your pi key on your calculator. My figure is telling me that my radius is 5, so I'm thinking 5 and squaring that, and then timesing it by the height. The height of your cylinder is 8.3. So when we're in our calculators, remember this is all multiplication, so you can multiply these in any order. Pi times 5 squared times 8.3. Again, if you're forgetting how to square a number, you're thinking 5 and then a little caret symbol, and then you can hit a 2, or take 5 times 5. Our job is to round to the nearest tenth, so when we plug that in, we should get about 651.9 cubic centimeters. One thing to note is that our label is labeled as cubic centimeters. The reason for this is because it's a three-dimensional shape and volume is always cubed. Some of you may be asking, could we put cm and then a 3 with it? Yes, you could. Okay, so you could have 651.9 cm raised to the third power, which also means cubic centimeters. Example 2 is asking you to find the volume of a cylinder with a diameter of 16 inches and a height of 20. You're going to notice on this one they do not give you a picture, and that it is in words. And also they're giving you the diameter this time. You have to be careful on this. When they give you the diameter, remember our formula is asking for the radius. So you have to ask yourself, the radius is half of the diameter. So if the diameter is 16, what's half of 16? In this case, again, we go back to our formula, V equals pi times radius squared times height. Pi times half of 16 is 8, so 8 squared, and then times 20, because they're telling us the height is 20. So when we plug that in, notice they're putting about They've changed it from the equal sign to about or approximately. So the volume is going to be about 4,021.2, again, cubic inches. So what I would like you to do right now is to pause this video and to take a minute to find the volume of each cylinder and round to the nearest tenth on Got It problems A and B. So go ahead and pause your video. After you have paused your video and come back, I have put up the answers for questions A and B. So you will notice the cylinder for A, your answer should be about 50.9 cubic inches. And then for B, when you found the volume of that cylinder, we should have gotten 565.4 cubic millimeters. Next, we're going to go ahead and move on to the next page. They do give us another practice problem at the top, example 3. This one is a little bit different. It says a metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does the paperweight weigh if 1 square inch weighs 1.8 ounces? Round to the nearest tenth. So there's two parts to this. First, we need to find the actual volume of that cylinder. So again, we're thinking V equals pi times radius squared times height. So as you look at the work that they have done here, they have taken V equals pi times 1. They get the 1 as the radius because remember the diameter is 2, so half of 2 is 1. We're squaring that. We know the height is 1.5, so that's where the 1.5 comes in. From there, then, they're getting the volume to be about 4.7. Now, the goal of this, or the object of this question, is to find how much the paperweight is going to weigh if 1 square inch weighs 1.8 ounces. We know that this paperweight is about 4.7. Okay, so from there we need to take 4.7 and we're going to multiply it by 1.8. So we're going to take our calculators out. We're going to type in 4.7 times 1.8. Therefore, we're going to get about 8.46. And they do ask us to round to the nearest tenth. So the paperweight is going to weigh about 8.5 ounces. Again, we took the weight of the paper, or the volume of the paperweight, excuse me, times the amount that 1 square inch weighs to get the overall weight of the paperweight. Go ahead and take a look at Got It problem C. You can go ahead and read through it and then pause the video and solve it. The answer for Got It problem C, when you are finding the average weight of the aluminum can rounded to the nearest tenth, should be 261.5 ounces. Last but not least in lesson 8.1, we're talking about volume of composite solids. So I'm going to talk about this real briefly here. Remember, composite meaning more than one. Okay, solids are going to be looking at three-dimensional figures. So we're going to be looking at situations where we're finding the volume of more than one solid. Again, composite meaning more than one. Solids would be the three-dimensional figures. So when we take a look at this one, they have a cube. Okay, and then what they've done is they've kind of bored through a circular hole in between here. So our job is to find the volume, okay, of each bead. So let me read this. Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of each bead. So normally if this part in the middle was not taken out, we would think volume, okay? In this case of a cube, we're thinking again, what is your base times your height, or you can also think length times width times height, or because it is a cube, meaning all sides are the same, we could think S cubed or side cubed. So what they've done is they've found the volume of the rectangular prism, okay, in this case 12 times 12, which was your base area, and then times 12 again. Like I mentioned, you could take side cubed in this case, and they get 1,728. Then they went ahead and found the volume of the cylinder. Again, that's going to be pi times radius squared times height. So radius is going to be 1 because the diameter is 2. You can see that goes all the way across. So they found pi times radius squared times height, and they've gotten that. Now, they're subtracting that because technically this is a hole. This is not filled in anymore because it's a bead, so the string would go through here. So they're taking the volume of the rectangular prism minus the volume of the cylinder, and then that's what they get overall. On the top of the next page, there is an example. Got It problem D, where they are giving you, it kind of is in a mailbox shape. So you can see you have a rectangular prism down here, and then you would have half of a cylinder here. So when we're thinking about finding the volume of this, what you're going to want to do is find the volume of the rectangular prism first. Again, that would be a length times width times height. And then you would find the volume of a cylinder, pi times radius squared times height. But you're taking half of it, so multiply that times a half. And then we need to add these two together. So pause the video, see if you can calculate it, and then we'll check your answer. Overall answer for the volume of the chest should be 49,771 and 8/10 cubic centimeters. At this time, you can go ahead and take a look at some of the other practice problems that may be in your book if you have your book at home or with you, or I have attached to this PowerPoint on the next slide some practice problems that you can complete, and then when you're done with those, you can feel free to check your answers.